Good morning, one and all. Hope I'm audible.
Good morning, sir.
Good morning,
Good
sir. Yes,
morning,
you are.
sir.
Good
Yes,
morning,
yes,
sir.
yes, audible.
Good morning, sir. Good morning, everyone.
Good morning, sir.
Good
Good
morning.
morning, good morning, all.
Good morning, sir.
Good morning, yes. So we'll just wait for a couple more minutes for others to join and we'll get started with our session.
Good morning, sir.
Morning, guys. There could be a small issue with the camera because thing is that my camera may not be enabled all the time during the session because this is on the mobile device, that's on iPad, so which will not support camera while sharing the screen. Okay, that could be one of the issue. Or don't get think on that. We'll go with the introduction of this session before we get started and everything. Also, we'll take a couple more minutes for a few more to join because it's not even 50% as on. Yes, so I hope this is the start of your semester, the very first class. Hope you had one more session in the morning, right?
Yes, sir.
Yes, sir.
So I have enabled mic for you all. You can unmute yourself and speak on. And I recommend you people to unmute and speak because when I'm sharing my screen, I won't be able to see your chat messages. But frequently keep checking after every 15 or 20 minutes. So anything you can unmute and speak on. Okay. Count as on. This is the best possible view that I can give it to you all. Should be good. So, fine. Shall we get started, guys? I think we had enough quorum to get started with our session for today. Right. Good morning. Welcome you all for a new semester with a new course, distributed computing. Okay. So my name, I'm Anil Kumar. I'll be handling this course for you for this semester. Okay. So I mean, I'm working with this course from more than like 12 years. Okay. It should be good enough to deliver to what is required to you people. Hope we'll have a good semester altogether by having valuable inputs from either end. So I prefer my session to be interactive. I don't want a monotonous one-way session to happen. Only I speaking all the time and just a mute participants is not what I'm expecting. So I'm setting my expectations and also I'll try to meet your expectations also. Kindly try to be more interactive. Okay. I prefer these sessions to be more of a discussion sessions rather than a lecture sessions. Okay. Where we can exchange our thoughts, ideas. The idea is that most of you are from the industry and you have some experience on all these things. So it's better if you can share your thoughts and ideas on the topics that we are discussing. It would be a learning for your peer members also. Okay. So everybody can share their thoughts, what are the things that they face in their day-to-day routine. Okay. We can discuss on them so that we'll share the knowledge among ourselves. So that is the way that I prefer to go with the sessions. You're not participating, I'll just go through the slides, I'll complete the things and I'll make my semester done. But I don't think that would be a fruitful thing to happen, right? Let's try to keep it more productive, make sure the things are more interesting, okay? And make it more interactive. Hope we are all together for that. Or you just want me to just complete the thing, whatever it is, and we'll just go through and make the things happen. That is not what is expected, right? Fine. So that way we'll try to make it more interactive, right? So before we actually get into the sessions, I'll try to give you a brief introduction about the subject course, where it evolves, how it starts, why do we need all these things. And based on that discussion, we'll take ahead with the content and the course syllabus to make sure what is our discussion and where are we heading to. So that makes us some context and prepares us some context to make the things happen in a much energetic way, right? So those are the things. Before we get started, what I'm planning to do initially is that we'll have a quick run through our handout, try to understand what are the topics, how the semester goes on, and the flows with evaluation pattern. Then we'll have introduction about the course concept. Then we'll get into the slide deck and make the things happen, right? So before we actually get started, are you all good with your e-learn portals? Okay. Hope you have access to everything, right? How many of you have went through my slides, which I already shared in the files and also in the e-learn portal? You can always find my content, preferably in the Teams of files folders. Okay. And also I'll keep a copy in the e-learn portal. Okay. So both are available, but mostly updated in the Teams at the earliest. Nothing big. So I have a slide deck which is clean, crisp, and clear, whatever we discussed. And post that every session, few annotations, whatever we discuss, that also will be made available. Okay, as an annotation slide deck. Fine. So now I'm trying to share my screen. I'm very sorry that the camera may go off because of the nature of this device that I'm using. Hope my screen is now visible to you. Is my screen visible,
Yes,
guys?
sir, it's visible.
Yes, sir. No
It is
visible.
visible.
Right.
Yes, it's
So
visible.
if you can get into the Teams, okay, you can see this is one of the course where you'll see my files. So in the files, you will find subdirectories in the class material. Hope you are able to see. You have files, the class material. Inside the class material, you have contact session slide deck. Okay. So this is where I updated the first 8 contact sessions content. Okay. The slides that we'll be using in our class. Okay. Post this, what I'll do is that I'll create one more folder here. Okay. Which actually will have it. Annotation slides. So the slides post our discussion, okay, from the class. I'll post it here. So we'll have the content of the annotation slides also here, right? So that's the way we go with. This is the content that is already available, which are not annotated. Just to give you a brief on that. Nothing big here. Our chat boxes are active. So I expect everyone to be active. Before I get started, any clarifications, any doubts, questions that you people have regarding the semester or what are the things that we are going through? Quickly in a minute or so. We are good, right? Fine.
Yes, sir.
Yeah. What I'm trying to do now is that we'll quickly go through the handout. Hope the handout is also available to you all. Okay. But there is a slight modification in the handout with respect to the evaluation pattern, which I requested the BitSit team to get it updated. They are on that way. Uh, the same handout is available in your eLearn or your Taxila portal. Okay. There's only 10% different, which I'll tell you with the evaluation pattern. Apart from that, this is a very good handout to go ahead with, and this is the thing that we'll be following. The course title are distributed computing, as you all can see, and this is a merger of 2 different sections here. One is for the CC and SS batches, both put together. So your course code would be CCZZ526/SSZZ526. Okay, it's a combination of 2 different badges came together. Okay, so the course outcome are just trying to understand the architectures of distribution, the communication models. Okay, I will have some kind of design aspects on how the software is being built on the distributed environment. We also understand the complexities and the resources that are required, and how do we manage the critical resources that are required, and how do we build a distributed system. And then it's purely about understanding different applications or the technologies basically that are built taking distribution at its core. Like say your Internet of Things, maybe clusters, grid, cloud, these are all part of your distributed computing. Let's try to have an understanding on that. Before that, the prescribed textbook, Ajay Kshema Kalyani, uh, I can say 60 to 70% of our content, mostly. Okay, I can say 80% of the content is from the prescribed textbook T1, that is the Kshema Kalyani. Okay, and a part of the contents are from reference textbooks which you can refer. Okay, so these textbooks are available in the market, and for your reference and for your preparation point of view for your examinations also, it would be better if you can procure a hard copy, or if you like to go in depth of the subject and try to understand more, you can go with the soft copy also. But for the examination point of view, you may require to carry only the hard copy, but not the soft copy. Okay, soft copy, you can get it. Just try to check on that, search for it, so that would be easily available, where you can go through that for a better understanding of the subject with more examples and elaborations. Right? So the learning outcomes, basically the entire course has been structured into 10 modules, as you can see here. There are 10 modules for this entire course. Okay. So basically we'll try to understand what distribution is. Okay. In the first module, we'll understand what is a distributed computing. Then we'll try to understand the logical clocks. In the third module, we'll speak about snapshots. Fourth module is about the basic algorithms that we have. Fifth module is about message ordering and termination. Sixth is mutual exclusion and deadlock detections. Seventh module is about consensus and agreement algorithms. From eighth session onwards, we see about the technologies that are developed taking distribution as its core, like peer-to-peer computing, cluster computing, and a few IoT. Okay, and we also speak about consistency and replication and distribution. The terms look little new or heard about, but may not relate much, so I don't want to go in depth of them as on now. Okay, I'm just quickly going through them just to make sure what is there, but you may not get the correct context of what we are speaking about. So the entire content is spread across 16 contact sessions. Okay, so till midterm it would be eight contact sessions content. So probably about 4 modules or 5 modules of the content. Suppose then the comprehensive exam, you have the entire content. Okay, we'll see about that also at a later point. Okay, you also have lab work for this course. Okay, so there is also a lab work. You can see there are 7 experiments as part of the lab. A lab we may not be able to discuss in class because of the limitation of the time, but the content will be made available to you in the e-learn portal, which you can practice through the virtual labs. Okay, you'll be given a virtual machine for about like 20 minutes or 30 minutes kind of thing. You can reserve them and start using them with some examples in the content that is given. Okay, based on which we will also create lab assignments. Now, I would like your kind attention for a minute here. So there are 3 evaluation components: EC1, EC2, EC3, as known to you all. EC1 component is like a continuous evaluation about your participation, quizzes, and assignments. So for this course particularly, we'll be going with online quizzes, just like 2 online quizzes, one before mid-examination and one before your compre examination, which would weigh for 5% and 5% of your marks. Maybe just like 5 marks and 5 marks is the weightage for your quiz. 2 quizzes, 5 marks each. Okay. Then you have lab assignment, which is for 10 marks, and the second lab assignment for another 10 marks. There's a small correction here, guys. Lab 2, I mean, you can see lab assignment 2 is for 15 marks, 15% weightage, but that is also for 10% only. There's a correction that I was speaking about. These contents are little need to be corrected, which you'll get it updated handout. Okay. So as of now, it's only 10%. Then, so your entire EC1 component is for 30 marks, 10 quiz, 10 lab assignment 1, another 10 for lab assignment 2. And EC2 component, which is a mid-semester examination, is for 30%. It's not 20, guys. As you can see here, it won't be 25%. It would be 30 again. Okay, this is the correction that I was speaking about. Sorry, it would be 30. 30 marks for your mid-examination and 40 marks for your comprehensive final examination, which would be open book examination. Your midterm examination is a closed book examination. And the lab assignments, mostly we'll try to do it in the form of teams. We'll form groups and we'll work along. Okay, we'll discuss about that after a couple of sessions once the lab virtual labs are ready and live. Okay, so this is the evaluation pattern, which is a 30 30 40. Just make a note of that. It's a 30 30 40. It's not like how it is shown in the handout. It need to be updated. You'll get the updated handout also. So this is pretty much about the course handout and the courses that we are speaking about. Any clarifications? Yes, please. Seems to be good.
Do you have only one midsem exam or two?
It's only one midterm examination and one comprehensive final examination. Midterm examination would be a closed book. Comprehensive exam, that is a final examination, would be a open book exam.
Okay, thank you.
Right. And in between, you'll be having your lab assignments and quizzes throughout the semester.
So for open and closed book exam both, so do we need to be present at the center for exam?
Yeah, it's a center-based examination. I think there is an exception for very few students who are abroad or something, which I'm not very clear about. Maybe you need to check with your coordinator, your operations team, who will be handling that. Exam dates are all fixed.
So who we need to contact for that?
Who's your point of contact? You might be having some course coordinator or your program coordinator, right? Where you are in contact with them right from day one during your registration and other things. Or you can write to support also. So that's the operations part that they'll take care of. I'm just concerned about the course delivery. Exam dates are fixed, but every exam has an option to go for a regular or a makeup exam. Okay. Hope you people are aware of that. The lab assignments will be involving any particular programming language. We'll discuss about them once the labs are enabled. Not necessarily to be a big programming language kind of thing. You can choose any of the language that you want. The purpose of this lab assignments is to make you understand few of the concepts of distribution in a more practical way. Nothing more than that. And you'll be working on them on your own. We may not be able to discuss them during the class sessions because of the limitation of the time. Okay. And I prefer this lab assignments to be taken as a group of 4 or 5 members. Hope you all are good with that and you agree with that, right? Rather than going with individuals. That would be a good team activity.
Yes, sir, group will be fine.
Yeah. Fine.
Yes,
That's the plan that I had for the previous sessions also.
Sir,
Any
one
other
question,
thoughts? Yes, please.
I mean, whatever you already uploaded, like 8 sessions you already uploaded, is it okay to take a printout for, open book,
No.
final,
No.
or you will share again at the end
I
of
will share
the
again.
course?
See, there is some change that is happening with the evaluation cell. So last year, what it was, can you kindly go mute? There's some background noise. So, Mr. Amit Kumar, kindly go mute, please.
Yeah, it's not from my end.
Yeah, maybe Ajit, please.
Ajit.
पढ़ल रही तो कबो पानी निकाले के बाद ज्वाइन हो जाए ना, मान लो प्लास्टर हो जाएगा तो फिर डालना मुश्किल हो जाएगा.
But it should be good now. Right. See, what I'm trying to say is that as of now, there is a small update that is coming up from the evaluation team. What they are suggesting is that the slides that I uploaded right now are also not valid or eligible to take it for the Congre exam because they want to create some secured based bookmarked or watermarked PPT format, which they are coming up with, which need to be used so that the same can be taken as a print for your examination. Maybe that call will be given after a couple of weeks. Okay, just wait for that. Don't be in a hurry to print them out. But content remains the same. It's only the format or the PPT template that is going to change. Okay, but not the content. Content remains the same. Should be good for your preparation, but might be too early for you to take a print of them for your compre examinations.
Okay. Thank you, sir.
So people like who don't have any coding or programming background, so there will be any coding or program need to be written during this course.
100% not. 100% no. But for lab assignments, you are required to code a little, where you can take help of any online resources or your teammates can be contributing for that. For which reason we'll try to go it as a team activity. Yeah, something like this. Somebody posted a sheet. There is also a change in the format now. This is not what it is going to be actually. It was a consolidated sheet which we used last semester. But this semester, the PPT that we prepare itself is a watermarked and secured thing, which can't be altered. So we need to wait for those instructions. Content remains the same. Don't worry about that. Mr. Niklesh. Stop worrying about the exams. Exams are not the concern here. So it's about the knowledge and the subject that we are trying to take in at a PG level. Okay. exams, if you are able to see my way of going with the evaluation or the question, if you are able to understand the concepts, you will be able to easily clear the paper. Shouldn't be an issue at all. Try to participate in the class. Try to be involved for the 2 hours. That should be good enough for you to go ahead with that. Hope I'm clear. There is
Yes,
no
sir.
coding, no programming in our course, but there are algorithms. We'll discuss how the algorithms are and what is the line of preparation also I'll discuss with you. Shall we get into the subject now? Hope you are all clear with the basics and other things.
Yes, sir.
There is something in the chat box. So in the previous semester, we primarily depended on the PPTs for exam preparation. For this semester examination, may we continue to rely on PPTs or it mandates to follow the prescribed? As of now, the PPTs are 100% allowed. Okay, that's the discussion that we had, and the prescribed books are also allowed. So coming to my subject point of view, what I do is that generally my PPTs are little more content oriented. Meaning, I'll make sure they are little elaborated just to make sure they are handy for your preparation and also for your examination point of view. It's not just like a 2 or 3 words in a line kind of thing. They are little elaborated to make this little comfort during the examinations. Most of the time, students claim that, sir, the PPTs are good enough for our examination preparation and also for the open book examination. Not really required to carry a textbook in most of the cases. That's how it worked. It doesn't mean that you can directly copy paste the contents of the PPT to the examination, okay, which doesn't yield you good marks. I kindly make sure of that. Where we can find full syllabus for the elective subjects before electing. I'm not sure about that, guys. Maybe you need to reach out to your course coordinator or program coordinator for that. I'm not the right guy for that. Hope we are good to start. No more questions, right?
Yes,
How
sir.
many units are there to
Yes,
come?
you can start.
Mostly it is about the 50% of the syllabus is for mid semester. We'll discuss before the mid semester. Don't be in a hurry for the examinations, guys. I'm giving you the confidence once again. Participate in the class. Just pay attention during my sessions. That would be good enough or more than sufficient for your examination preparation. Okay. Don't worry much about the exam. Exams would be a cakewalk for you if you are attentive in the class. Just participate. That should be good enough. Okay. I know you people are all experienced, might be more elderly than me also. So the purpose of you people coming here mostly to get some knowledge and acquire a PG degree. Let's try to make it in a more useful way rather than just another degree added to our feather. Okay. So now let's get started. I'll straight away go to the PPT. So slide deck. The format of these PPTs may change. We are waiting for the inputs from the operations team. They want to give that watermark once, which would be easy for your examination point of view also. Okay, that's under progress, but the content remains the same. Don't worry about the content. It should be helpful. So as said, the course is coded ZZ526. Okay, this is the core code of this course, distributed computing. Okay, and my name is Anil Kumar Gadiyaram, and this is my mail ID where you can get reach to me. Generally, I try to respond within 24 hours max. Okay, might be a delay in case if anything goes wrong. You can also ping me in the Teams for anything that comes up. Okay, so I'll be available throughout the semester to be in contact with you for any critical issues. Right? I've started the recording. Recheck once again. So first session we'll try to go a little slow and just try to be in the flow. Not an issue. So the first contact session is from module 1 of our course, which speaks about the introduction to distributed computing. This is part of your textbook chapter 1. Most of the content is a part of your Kshema Kalyani. This is the prescribed textbook that I was speaking about. Ajay Kshema Kalyani. Just try to have a copy of this. Try to have a soft copy. Then, if you feel comfortable, you can get a hard copy of the same. Okay. And these are the other reference textbooks. Okay. Which are covering a part of the syllabus based on the particular topic that we'll be looking at. So module 1, the objective is to make sure how distributed computing model works, what are the hardware and software components of that. Okay, and in this module, we'll see what distributed computing is and what is the communication model that we have when they try to speak with each other, and what are the design challenges and the issues. Three basic topics that we'll be covering in this module 1, which is Introduction to Distributed Computing. So I said the introduction to distributed computing. So the topics are motivation, multiprocessor, and multi-computer system. So we'll be seeing why distributed computing has evolved, what made the distribution come into picture. Okay, then we'll also see the communication models, as I said. So like RPCs, publish, subscribe, and message queues, three different models we'll just discuss. And we will also see the design issues and challenges. Three basic topics, the motivation factors, why, what distribution is, then the communication model, and then the design issues. So these are the topics that we'll be looking. So let's get into the first topic, introduction to distributed computing. Before I get into this introduction, I'd like to understand from you people, okay, what is your understanding or what is the context that you have about what distribution is? Any idea? What is the distribution?
Yeah, so basically, single computer is not sufficient to handle a load, and so that the design pattern come up like to use multiple machine instead of single machine to fulfill that requirement. And this
Okay.
is the this bring a era of this distributed computing where we have a multiple nodes as a machine, and that
Okay.
all serve at one task or multiple
Okay.
tasks altogether.
Okay, that is one way of understanding distribution computing. Anybody else would like to share what is your thought about distributed
And
computing?
also it is applicable to within machine also means some of the area of the software it means working on different segments and they are collaborating with technique like message queue, publisher, subscriber, remote processor call
Those are all the
using their
communication
communication.
models.
Yes.
Yeah, those are all the ways that the machines speak with each other. Any other understanding? Just a layman thought about what distribution is.
So
Not necessarily.
processing
Yeah.
and storage are not handled by a single device, like multiple devices handle that.
Okay, so it's a subject speaking about accessing multiple devices at a time for a particular task. Can I say like
Sir, yeah, sir is a computing system in which the tasks are shared and executed by the multiple interconnected computers. Like Google search, millions of servers work together.
Okay.
And cloud service. Yeah, yeah.
Okay. Then anybody else? What is
So
your
we can
understanding?
say these are the redundant systems divided across the different regions to make sure that in terms of availability, we can ensure that the system is available all the time in different regions,
So you feel
redundancy, resilience.
availability is the factor for which reason you want to go for distribution.
Availability as well as, yeah, basically availability, yes.
Okay.
System resilience.
Okay.
Yeah.
Scalability is another thing. My handwriting is bad, guys. Don't mind.
A complex a complex program is distributed to multiple systems to work on it and then collect the outcome of it to produce a better and performant solution.
Collaborate and integrate. Can I say it as collaboration and integration?
Yes.
So to meet the load, before that it is to meet the load of multiple requirements that we have. Since one machine is not able to make it, multiple machines come into picture. Then any other understanding?
It's a parallel computing.
Allocation and deallocation of
Parallel computing to reduce the turnaround time of the operation.
Can I say to raise my performance?
Yes. And turnaround time.
That's what. Reduce the response time and increase the performance.
Yes.
Then
We have one another reason for having the distributed computing systems across different countries And that is the regulations and the compliances, because you can see that in different regions we have different regulations like GDPR.
So that
kind
is
of
all about the operations part. So since we have distribution, we need to have regulations. It's not that for the regulations part we have distribution. Am I right?
Correct. Yes, absolutely.
Yeah. So that might not be the whole reason for having distribution, but regulations and compliances come into picture because we are on distribution. Okay, that will take it. Then
Is it for the using of the systems like underusing the expensive hardwares so that financially it can be helpful?
economical.
Yes, economical.
But how do you feel it is economical? We'll discuss.
Um,
We'll discuss. Make a note of this.
okay.
Okay.
Yeah, sure.
Can I turn it
So
on
one,
efficiency?
Yeah.
Justified?
Yes.
We'll see how these both are related. Then
It's kind of a
Sending
distribution of work
towards
and load.
sorry,
It's kind of distribution of work and load from
but
one
that
to
already
many.
to meet the load requirements. I made a point. Don't
so
repeat.
sending messages across the world, like a kind of networks, what do worldwide?
No. I mean, since there is the distribution, the communication should happen. It's the other way around.
The fault tolerance, if once one of the system is getting failed, it won't
Okay,
affect
I'll
the
just
entire
make it
system.
as fault tolerance. Okay, fault tolerance is one of the reason why we need to go for distribution. Accepted. Fault tolerance mechanisms need to be developed.
One other thing is the business continuity planning.
Okay, part of business continuity planning that is there.
Distribution, like kind of a
Accessibility
small,
to end user.
Sorry, distribution.
If it is
like a small.
distributed across regions, then it will be accessible to end users, spread across geographies.
That is what I said. The availability factor that speaks about the first point. Availability factor.
Sir, time saving or maybe redundancy.
Fault tolerance. Okay, replication. I'll make a note.
The distributed systems are kind of collection of systems connected all together to network, and then they are actually working on a single or a single task, which are actually divided and distributed across the different nodes. So
Perfect
that
definition
is
of a distribution.
correct. So ideally, this is what generally the primary purpose of distributed system. But
True.
along with along with that, we can achieve all these scalability, reliability,
Yeah,
fault
these are all the
tolerance, etc.
properties. These are all the
Correct.
properties that will be built in
Yeah.
when we achieve when we go for
Ideally, they are the
distribution.
connected system who are actually working on a single specific task or which are divided across
True.
that.
True. We'll
And
see
they
both
can
ways.
they can be scattered either within the premise or on a different geographic location as well.
Okay, remote access.
Resiliency.
Resilience. Okay.
Decentralization of the task.
Decentralization. Perfect term to be coined for distribution. It is a decentralization.
Easy maintenance.
Efficiency economic comes into the maintenance part. Yes.
Okay.
Modularization.
Modernization.
Not modernization. Modularizing
Modularity.
things.
Yes. Scalability and modularity. Yes, they are part.
Performance.
Yeah, I disclosed, made a point. The increase in the performance. No,
Data protection enhancement.
Security. We
Yeah,
have everything is security. I have a question for you guys. You answer me later. We'll have a break after that. You answer me. Make a note of the question. Which is the most secured system in the globe? Okay. The most secured system. I want you people to answer on that when we speak about security. Which is the most secured system in the globe? We'll discuss about that. Just remind me. Okay. Maybe by end of the session. Now, I have a question. Is the distribution part of hardware or software?
Hardware.
Both, sir.
So we are doing distribution at hardware level.
Both required.
Both.
Sure.
Yes.
I believe it's hardware.
Yes, sir.
We'll see.
No,
We'll
hardware.
try to justify. We'll see whether it is hardware, software, or it is both. Now there's a beautiful discussion. So I'll pause you people here for a few minutes. I now understand that you have a very fair idea on what distribution is, but for the other people who might be new to the subject or might not be working on this environment, I'll try to give a brief on how the things went on. Maybe but the people who already have an idea also can look into this, how we just started. So see, let's assume we have a standalone system. Okay, a user is able to access it, single user, single machine. Okay, but the applications and the evolution so developed that we require multiple users to start accessing the system, where I created software components which are now multi-user accessible. Okay, single machine, multi-user systems is what was a term that was coined. And how many users can I make access this single machine? Single machine, maybe PC is not a curt term, maybe a server. I'll call it as a server. This is good enough for me to access 10 users at a time. Now my user count raised to say 50. What is the solution that I need to come up? This machine is good enough only for 10 users, but if I want to make 50 users work with this machine at a time, when I'm referring to users, it's not that users just getting connected, but users who are trying to do a scalable work. Okay, on the same machine. Multiple users are trying to do some scalable work on the same machine. Okay, so when I say when my count raised from 50 to 100, would the same machine be good enough for me? No, I need to go
No.
for a larger box. I'll try to define it as a server, a little larger box where I'm able to accommodate more number of connections. It's not just with respect to the network. I'm also speaking about the capability of the machine with respect to its processing power, which is given by your microprocessor. Okay, where I have like 8 to 16 processors in my box with the primary memory or the main memory, which you generally call it as a RAM, and maybe few gigabytes, maybe 32 to 64 gigabytes. Okay, so what else do I require in a machine to be called it as a computer? I have a processor, I have a memory module, which go both hand in hand most of the time. Am I right? A processor and a RAM. Generally, we call it as a RAM, but a main memory or a primary memory module. What else is required?
Storage.
So I have a basic storage component called as hard disk, or nowadays we are having SSDs, maybe few terabytes, 1 to 10 terabytes. Okay, so I refer my storage something like this. So these are the three basic components that are required for my computer. Accepted?
Yep.
Or anything else? Let's not speak about the USB ports, box, monitor, keyboard. Those are all the peripherals. Okay.
And these are the
High,
basic
high
components
speed,
that make up
high
a
speed
system.
net,
What is
high speed network,
network?
high speed
Which I try
network.
to call it as. So can I term it as NIC, network interface
Can it?
card
Yeah.
for my network?
Yes. Network internet.
Okay. I don't have a proper diagram for that. Just a cable. Okay, Ethernet. Okay. So depends on the bandwidth, any kind of communication model. Let's not restrict this only to TCP/IP protocol. Okay, it can be TCP/IP, Ethernet, optical fibers, or it can be Bluetooth. Okay, it can be NFC, or it can be like Wi-Fi. Any kind of networking protocol, Zigbee, any kind of networking protocol which I require. Why do I need this networking protocols? Why I need a network interface card? To make sure my machine is now able to communicate with the other machine. See, for my 100 users or 50 users also to get connected, I require a network, right? They don't plug in directly. They don't come and plug in directly their keyboard and mouse to start working, right? So via network, they'll make it. So these four are now termed as the basic resources of a computer. How many of you will accept this? These are the basic resources of a computer. Initially, it used to be only processor, RAM, and storage. But now, with the evolution from the last couple of decades, the network is also the basic component, without which we can't realize a computer. Would anybody prefer having a mobile device without a network, a data network, or would anybody prefer having a laptop or a PC or a huge gaming machine Without a network, there is no point. We stopped working on the stored content. We started working more on the online content, right? So these are the basic reasons. Now, what I'm able to do, since I want to make 50 or 100 users to be part of this, okay, I raised my basic resources from a single processor to multi-processor, okay, 4 or 8 GB of RAM to 32 or 60 gigs of RAM. And the storage capacity, it is a dynamic based on the need of the application. We are able to scale it up. And the network bandwidth also need to be increased here since it need to accommodate more number of users. Would this be good enough to support any application that I am running on this machine? I have an application which I'm running on this machine where 100 users are accessing. Would this be good enough?
No.
No. So this is
No.
case one. This is my case two. No. Let's assume the number of users started increasing to 1,000. What is the point?
Then we
Is
will
my
need to
machine
scale
still,
up.
is my system still good enough to go ahead? No. So
No,
what
we
is
will
the
need to
solution
scale up.
that I had? What is the solution that I had? I simply scaled up my machine by adding few more processors, but with the hardware limitation, with the number of ports. Okay, can I add 100 hard disks to my computer? No, maybe max 10 or 15 based on the porting capacity. Can I add up keeping on 100 slots for a RAM? No, it might be
No.
limited to 4 or 8. Number of processors, maybe 4, 8 or 16 max, not more than that. So rather, I would add another server. Would you accept server 1, server 2? Add up one more server and let them be connected with each other. And this all looks like one large server to the users and they start connecting. Accepted?
Yes.
So now I'm
Yes,
able
sir.
to scale it somewhere between 500 to 1,000. You may ask me, sir, in the first case, it was only 100 users, one server. If two servers, it should be 200 users. Okay, but why 1,000? I'll say because of the evolution in the hardware technology, the Moore's law and other thing, now my machines are so good that each machine is now able to support 500 users. So now I am able to have just two servers to make them use for 1,000 users to work on. Case 3 closed. I'm able to satisfy my application and my users. Yes, it's going good. Now, the thing started is that let's assume the world of social networking. The number of users are
Millions.
millions. Hundreds and thousands of users are coming up. Let's forget that far end case. Let's discuss about a enterprise case. Let's have an application which has been built by an enterprise to work with its own employees. Okay. The count would be somewhere about hundreds of thousands, maybe 10,000 or 1 lakh or 100,000. Am I right? So what if I have 100,000 users? Would the same environment be good enough for me? No. You may
No.
scale up with more
No.
number of machines. You may scale up with more number of servers, but still it is called as a centralized environment. Am I right? Both
Yes,
are
sir.
centralized environments. The first case is a standalone machine. Okay. These centralized environments have their own limitations with respect to the number of connections, the load of the application, and how much of work that they are doing. Okay. So when I'm speaking about an application that is accessing all these machines, I mean the application that is being available in all these machines and users are trying to access that. The loading is the major thing that comes into picture. They are not able to take the load. When I speak about the load, what is the load I am speaking about? Is it the user load? I mean the number of users, or is it the application load? Very important.
Oh,
What
I
do you mean
think
by
both.
application load?
Both should be.
Both.
It is both actually. Users can be managed by the connections, but the application load is something that is coming into picture. When I speak about application load, our applications are so large, so huge, and the data with these applications, data is another concept. The load of the data is another thing that is coming up. Okay, to manage my application and the data, the servers are not good enough or sufficient enough with the load that is coming up. When I say an application load, to run its front end, back end, and the middleware services, and to connect the users, and that's a separate networking altogether, and to have the data of that particular application, the amount of data that is coming up for that application. I'm not speaking about any databases. Okay, if we speak about databases, they are purely data-driven applications. I'm just speaking about a regular application, which is both process intensive and data intensive. Do you accept? Process intensive applications, data intensive applications, maybe both at times. Can you cite some examples of process intensive applications? All your machine learning and AI applications are more process intensive applications. Accepted? They do a lot of processing, weather forecasting,
Yes, sir.
other things. Data intensive applications, classically we speak about databases, okay, big databases and other things. But with the current trend that is going on, if you want to work on an AI application, it is both process intensive and also data intensive. It is process intensive because you need to work on a lot of data, like the big data application. The data is getting processed to analyze, understand, and come with a proper understanding. That's where the process again comes into picture. So there is a need for both process intensive and data intensive applications to be hosted on my servers. For that to happen, think about the scalability of your servers that you require. They should be large enough. I'm not just speaking with respect to the amount of processing power, the amount of RAM, or the amount of storage that you have, but also the coordination about these things. Okay. So for that, we need to understand how we can go ahead with that. At this right junction, I'll try to give you an understanding when I speak about process intensive and data intensive applications. So the subject that deals with the processing part of your computing is a okay. Before we go with that, I'll just draw a line here. We'll wait here. We'll come back. Okay. Now, since multiple servers are not able to give me that intensity of the applications that is required to me, I'll go for a much okay. I'll go for multiple servers. Server 1, server 2, server 3, server 4. Maybe likewise, let's limit it to only 4 servers. And all these 4 servers speak with each other. What is the need that these servers need to speak with each other? Because they all are hosting one single application. And this is the network to which users gets connected with their machines. Both ways. Okay. So what I'm trying to do here is that there is a private network here. Private network to which the servers will speak with each other among themselves, and a public network through which the users or the applications get connected to the server. Of course, there would be a linkage between them. Okay. So for the servers to speak with each other, we have a private network. Why the servers need to speak with each other when they are all running the same application? Can't I divide 100 users to server 1, 100 users, maybe 1,000 users to one server, 1,000 users to another server? That again comes to the same concept like the older one, like a centralized environment. I don't want to limit my users to connect to only one server and get access whatever they want there, because my applications now are not good enough to run on a single server. Though my number of users are 50 or 10, the application is not good enough to handle in a single server. My application is now required to run across multiple servers. Meaning, when I say multiple servers, okay, if I have an application, I'll try to cut that into multiple services. One is like for a data collection is one job. Okay, analyzing the data is another job. Okay, and processing the data is another job, and reporting this data is another job. Maybe just take an example. These are the 4 functionalities of my application. I can run all these 4 functionalities on a single server, provided the data is smaller. I'm not speaking about the user front now. Let's forget about users for a while. Okay. Now networks are good enough. We now have the confidence that multiple users can get connected to multiple servers at the same time. Now I'm worried about the application. The application, though it is able to run all its functionalities on one server, the amount of data that it need to handle is not sufficient enough. The processing becomes lower, and hangs up at times. For which reason, what I try to do is that I allocate one server to do one part of my application, where it's about data collection. Second part to my second server, third part to my third server, and fourth part to my fourth server. Likewise, I am distributing the work across multiple servers. Okay, I am distributing my work to multiple servers. Okay, that is where I call the concept of distribution. Am I clear? So here I am distributing my work across multiple servers. You may ask me, sir, why? What if my application is not that heavy with the functionality? Okay, my application is good enough that it can run on a smaller server also. Okay, so I'll include all the four functionalities into one server. Might be my application is small enough to run all four functionalities on one server. Good, I will do that. But what if the data that is coming up is huge, where one server is not able to handle? In which cases, what I'll try to do is that I'll replicate this application across four servers with all the functionalities. Okay, all the four functionalities are given to all the four servers, but they work on different set of data, not on the same set of data. And they collaborate, coordinate, and come to a final conclusion how they need to work. Okay, so that depends on how we want to distribute. We can have our own way of distributing. Okay, how you want to distribute your application. Okay, that's where the concept of distribution comes into picture. Am I distributing my work or my data? Is what I need to decide. What am I distributing? Is it work, data, or and? Is it both or either of them? That depends on application, and it varies from application to application on different concepts and different aspects. Not necessarily it's all same at all the times. Able to get my point, guys? Now, when we speak in this context of decentralizing our work to multiple servers, it is as good as multiple men are working on achieving a single task. The task is defined by my application. Okay, now I have a task or a job which need to be executed. Okay, where multiple servers come into picture to get it done. I rely on a larger, a larger resource pool to work on them. Okay. Now, in order for me to make this larger resource of pools to work, I require a proper coordination among these servers. Now, the subject that we are now trying to deal, the distributed computing, is about how these servers are able to coordinate with each other at different aspects, and how do they work with each other, and what kind of distribution will we be doing. Would we replicate the application functionality across all the servers, or would we divide the work across multiple servers? If so, what are the challenges, how they work, how do they come over, is what all we'll be discussing here in this subject called distributed computing. So when I say it's a process intensive application, okay, coming back here, when it is when it is process intensive, okay, and I'm working with something that has to do with the processing part, which means about my microprocessor plus my RAM, that is my main memory. This subject I try to call it as a distributed computing. This is where we land. Why distributed computing we should learn? We need to understand how this distributed processing is going on, how resources are being utilized, why we need distribution or computation. We are distributing the computation, the processing part, the work part, the hard work that we are speaking. Okay, that subject is called distributed computing. Now, when I come to data intensive applications, I work more on my data storage, distribution of data across multiple machines, storage of data across multiple machines, replicas, redundancies, fault tolerances. Okay, the subject which deals with all these strategies is called distributed data systems. Okay, so I think you people might have completed this course in distributed data systems, or you are about to complete, or you may not even touch also, depending on your program structure. I'm not pretty sure about that. But now what we are dealing is with distributed computing. So just to brief on, to understand, distribution can be at a processing level or can be at a data level. The subject that deals with the distribution at processing level is a distributed computing, about the computational part. And the subject that deals with the data part of the distribution is called distributed data systems, which we are not dealing now. Okay, I mean, I'm not sure it's part of your course curriculum or not, but we are dealing with the distributed computing, the processing part. Okay, am I clear with this? Any doubts or questions on this, guys? Hope you are connected. Absolute silence.
Clear, sir. Clear, sir. No doubts.
Clear, sir.
Just take a minute. Hope my screen is visible. Go through these different components. Okay. I'll just get clear once again. So this is the first component that we need to discuss. Second component that we came across. The third component. This is how the evolution came on. That's when the distribution came into picture. The fourth component is also your fourth component. Now we'll be discussing and concentrating more on this part. How servers are able to communicate among themselves for executing a task or an application, a particular work, not everything. Okay, that's where we stand. This is what is dealing with distributed computing. How they work together. It's about the collaboration and coordination. Take a minute just to go through this all through. Doubts, questions, kindly fire it. Now coming back to the question, is it hardware oriented or software oriented?
Both.
Again, it will be
Hardware.
both.
It is actually software oriented,
Both. Yes.
It's both in fact.
detected by the hardware.
It should be, see, because the hardware is getting distributed, we can't have entire hardware on a single board, right? Since the hardware is getting distributed, software also need to be distributed. So by default, it is both software and hardware that is getting distributed. For which reason we distribute both processing and data. Since hardware and software are distributed, the processing and data are now distributed. Accepted?
Yes, sir.
Fine. Check the chat box.
One question, sir.
Yes, please.
Like hardware, in terms of hardware distribution, I understand, and we feel that like we have multiple computer, and we when we mix all the computer, it will become a distributed kind of thing. But do we need any sort of software as well parallelly to make a entire distributed system to work in one go?
Yes. That is what computing. That is what will be discussed. Exactly. That is the line where we have object. We'll discuss that. Others may get confused. That is where I'll try to introduce what distribution is in next few minutes. That is the
Can you, sir,
exact layer.
please come again? I lost that.
We'll,
What
don't,
was
don't
that?
get confused. Don't get confused. We'll go through that after a few minutes. Don't be in a hurry. There are a few questions which I'd like to quickly take it in the chat box. Of networks, load balancing, task is divided into multiple segments and processed by multiple processors, often working together in a network. Perfect. Distributes the incoming traffic to multiple instances so that we can scale and know any system is idle or overloaded. Perfect. Stability, better availability. Distributed computing makes services scalable and more efficient for the target audience. Users providing seamless transactions. Yes, it's a user experience is great in this. It is introduced as the load and demand increasing and single or multi nodes of hardware and not sufficient for the transition. It's both hardware and software, right? A telecom provider with customers spanning Asia and Africa would need to integrate distributed computing to help cater to customers all the time without interruption. There's a high availability option that we are saying. A good example to go ahead with. Yes. Fine. It's all embedded. Right. So I have a bad habit, guys. I don't know whether you'll accept or not. Based on your interest, we'll take that. I prefer taking a break for 5 minutes after every 25 or 30 minutes. Okay. Maybe you will refresh, I'll refresh, or loading the content continually may not work. So is it okay with you all? We'll go for a break after like a 25, 20, 30 minutes based on the context. We'll break at a particular context and we'll go for a break.
Yes, definitely. Yes, sir. Fine.
Yes, sir. Two or three
Yes,
breaks in
sir.
a session. I think that actually works. Otherwise, it becomes monotonous and the things may not get into actually. That's what I believe in. If you're okay, we'll go for that. It's not that I just want to spend some time. It's only to refresh ourselves. Maybe, or otherwise, we can speak something out of the topic also in this time. Are DC and DDS work together to have distribution system? Yes, perfectly. Distribution is either processing level or data level. If it is processing level, it is a DC. If it is at data level, it is a DDS. Both put together is distribution. So we'll have a quick break here, guys. Break for
What
5
is
minutes.
D-
We'll come back and continue. Sorry, what is?
I had a question. What is DDS?
Distributed data systems is another subject. Okay.
Okay,
I don't know
it's a
whether it is
different thing.
part of your program or not. That is a subject which deals with the data. Distributed computing is the subject that deals with the processing of the applications. So we'll
Okay, it's
be
the
concentrating on the
computing
DC.
part.
Yeah, it's the computational part. I just want to create that relevance. Where are we standing? So without the context of understanding where we stand, going with the subject may not actually make sense. By the time we realize where we stand, we might be done with the sessions also. So I create these introduction sessions by myself. I know it takes some time, but we'll compensate the time. Shouldn't be an issue. Right? So we'll have a quick break. We'll come back. Any doubts or questions? Make it ready. We can discuss. Right? Yes. Let's resume back, guys. We all good? Are we in sync?
Yes, sir. Yeah.
Yes, yes.
Yes, sir.
Any doubts, questions?
Yes, sir.
Anything before we go ahead? So I'm not in a hurry to complete the content, guys. I'm more confident that syllabus would be completed. I would like to have more discussion and understanding of the subject. Tell you one thing. The first 50% of the syllabus is more intensive, meaning we need to have a better understanding down the line so that we can understand the other concepts. If we miss the basics, it will be tough down the line. So we'll spend good time for a better understanding. Let's not fix ourselves to go with the scheduled structure, which may not actually meet. Okay, so we'll be lagging a little by 1 or 2 sessions by mid-examination. That is what generally happens with me with this subject, because the course is structured in such a way. Let's not worry about that. We'll make sure we'll have the understanding. Post mid, the subject will go much faster because it will be a smoother flow. The content is little less. Okay, we'll try to compensate there. Right? Let's not worry about completing the syllabus in a particular session. That may not be more productive. Fine. Can we go ahead?
Yes, sir.
Here we are. So let's now get into the definition of what distributed computing is. Okay? So distributed computing, which is a field of science, field of computer science that studies the distributed systems. The distributed compute system is a software system in which components located at networked computers communicate and coordinate their actions by passing messages. Very important line. Read for yourself for a minute. It's a system. It's a software system. Meaning, when we speak about distributed computing, it's a software component, okay, with components located on networked computers, meaning the hardware at different locations. Okay? Machines at different locations are getting connected with the help of software. Okay? The purpose of this software is for communication and coordination. Why do they need to communicate and coordinate it? So that they can achieve a task. And the way they communicate and coordinate is by passing messages. Okay? This is one important thing that you need to keep in mind. The way these servers or machines speak with each other is simply by passing messages. Okay? Via network. A distributed system is a collection of independent entities. Not necessarily they are all homogeneous, similar, same type, other thing not required. They are all independent on their own. And they come together to achieve a task. That cooperate to solve a problem, meaning the task that they need to work on with, or the job that they are given with to work with, that cannot be individually solved. Very important. Something that can't be done on a single machine, which requires the support of multiple machines to come together and get it solved. That's where the concept of distribution comes into picture. So we are able to now relate with the discussion that we had initially with the definitions of distribution. Right? So simple thing, same thing, multiple independent machines with no physical common clock. This is another important factor which we'll be discussing in module 2, next sessions. Okay, no physical common clock. Just keep that in mind. We'll discuss about that later. No shared memory. First point, no physical clock. Do you think all machines have the same clock timing? Yes or no?
No.
No.
It is possible. They drift by a fraction of a second, okay, which is not good for distribution computing. We'll speak about that. We have a separate module for that. Okay. No shared memory. Could, if I say there are 100 processors which are participating in a task, okay, could all 100 processors be communicating with a large pool of, let's say, 10 terabyte of RAM memory? That be possible? No. Okay, it's not a single shared pool of memory. It's a virtual memory that you create by logically pulling individual modules into one large memory. So there is no shared memory. But somehow a global state needs to be created when required. You create a logical pool of this RAM. Okay, multiple machines RAMs come logically as memory module, and there they start working. Okay, meaning the RAM of each machine will speak with the RAM of another machine. I'll show you that. Maybe physically distinct machines. Accepted? Not necessarily all these 100 machines or 1,000 machines are at one single place, single building, or in a single cabinet or in a single box. They are all spread across multiple locations. That's the beauty of distribution, actually. That's the purpose of distribution, and the beauty of distribution is that it is able to coordinate, relate, and work along with the remote machines which are globally spread across. Not necessarily they are all at one single place to work along. Okay. Physically distinct machines and needs good network infrastructure, which is one of our basic computing resource, and protocols, control algorithms to communicate. Meaning, having the hardware infrastructure is not just good enough. You may have a very good communication, higher bandwidth, the machines are able to speak with each other, but you require a driver for that. That's the software component, the soul. Okay, the software component comes into picture to make this happen. That's where your protocols come into picture, the algorithms come into picture, the control algorithms. Okay, that is the subject that we'll be discussing here. Machines communicate via messages, and somehow the system figures out the message order. We'll discuss on that also. We have a separate session on the order of the messages. Okay, so they communicate by passing messages. The machines are doing pieces of work can jointly figure out when a task terminates. You also need to understand when the work has been completed, which is called as a termination detection. So these each individual point are the different modules that we discuss. Okay, it will be too early to understand. We'll go through them one by one. Now, a distributed system can be characterized as a collection of mostly autonomous processors. Yes, please.
Yeah. Can you go back to the slide, sir?
Yeah.
Yeah. Regarding the second point, no shared memory.
Hmm.
Yeah, so among the distributed systems, they actually maintain which data set to be processed, right?
Yes. The memory is
So,
the RAM that I'm speaking, not the storage. Forget about storage.
okay, not the storage, but the parts, like which subset it is to be processed, something. Those are not considered as this one.
No. See, what happens is that let's assume I'll take database as an example most of the times. Okay, just to clarify your question. I have a table which is of 100 GB size. I have a query to get a part of this table which is 1 GB in size. Okay. So would I process this 1 GB on a one single machine? May not be intensive enough. So what I try to do is that this 1 GB of data is broken into 4 pieces, and each piece is executed in each machine. So 4 servers are allotted to execute one piece of data at a different machine. Okay. Now, where the data goes, this 1 GB spread, meaning 250 MB each, goes into which component of the computer? It's the RAM. Okay. Logically, this entire 1 GB is at one place, but physically it is divided into 4 different machines across 4 different RAMs, so that the 4 different processors will work on that data individually. Able to give the clarity?
Yeah.
It's not that you are having entire 1 GB at one place and asking every processor to communicate, come here. They will do that. But the problem would be the lag would be higher. The response time will come down. Okay. We'll discuss that also. You'll understand more on that. Fine.
Yeah.
So here, as you can see in the figure, is a processor memory put together, meaning individual machines. Okay. They're all working individually on their own and also communicating over the network to make sure they achieve a common task. This is a private network that we are speaking about. If people are aware about rack, anybody would have worked on rack. It's not there anymore. Real application clusters of Oracle. They can relate a lot in this. So now, what are the characteristics of distribution? When we speak about distribution, okay, so a distributed system can be characterized as a collection of mostly autonomous processors communicating over a communication network. What are the features? Very important. No common physical clock. Keep these points in mind, guys. These are very important. So these points apply throughout your course. There is no common physical clock, meaning not all machines work with reference to one single clock. Am I right? The timing varies from machine to machine. They don't have one common clock. Okay? Second thing, no shared memory. There is no shared memory that is available where there is everything so that everybody can come there and access. It's not practically possible. They work on virtual pool memory, but not on physical shared memory. Okay. Geographical separation accepted, meaning the machines are not necessarily to be at one place. They are spread across multiple locations. Nowadays, we are seeing the concept of data centers where we have 50,000 or 100,000 processors at one place and they get work on. They are built for a purpose. But the concept was machines which are spread across multiple locations are logically pooled and made to work their local job and also their remote job so that you can effectively, efficiently utilize those resources. Okay, that's where geographical separation plays a very key role. For the purpose of geographical separation, we go for distribution. The machines are spread across multiple locations. We bring the concept of distributed computing so that they are all collaborated, they are all linked with each other, they work collaboratively to achieve a common task. Okay, this is another major fact. Autonomy and heterogeneity. What do you mean by autonomy? Every machine can work independently on its own for the given task that it has been given. Okay, they have their own control. Okay, and heterogeneity speaks about, when I say there are 50,000 processors are deployed to do a task, we have such a task, or to run an application. Okay, or I say my application has been deployed on 50,000 processors. Do we expect all these 50,000 processors to be homogeneous, meaning they are all of the same configuration, same vendor, same manufacturer, same firmware, same platform, okay, same memory modules, same operating system? Would that be possible?
No.
Can be made possible, but would that make sense? If you
No, sir.
make that happen, the efficiency economical factor doesn't come into picture. Meaning, the application should be able to work across platform. Yes, I can say my application one can work on Windows and also on Linux and also on Unix on multiple servers. But can your application relate the work done by a Windows machine, Unix machine, and a Linux machine together and correlate and work? Yes, that happens in distribution. That's where the point of heterogeneity comes into picture. Not necessarily the workers, meaning your processors, okay, or your machines or your servers, which are meant to be part of distribution, and the application is running on multiple machines, not necessarily they are all homogeneous. They can be extremely heterogeneous. Still, your distributed computing environment should be able to support, work along, coordinate, collaborate, and get your task done. That is the beauty of distribution. Okay, there's a major advantage that we take with distribution. Four important points, guys, where the entire subject goes around the distributed computing. There is no physical clock, no common clock, no shared memory, no totally geographically separated. This is the extremes that we are speaking. Okay, they can be extremely thrown out at the different corners of the globe. Still, they should be able to communicate, coordinate, and work. And they are highly autonomous and highly heterogeneous. Still, they should be able to do. For these purposes only, the distributing computing has been evolved. The concept of distribution has evolved to make all these come together and make the things happen. Clear on this?
Hi, sir.
Yeah.
Yeah, I just have one question on autonomy and heterogeneity. So, like, let's say, if one of the device, I am having two or three servers, if one of the servers is like, quite slow. So eventually we will be waiting for like, a response from all the servers and then showcasing the result.
Yes.
So if any one of the machine is slow, that will effectively lead to the slowness of the entire distributed system, right? So will that autonomy and heterogeneity make the distributed system more slower?
No. Here, that's where the role of distributed computing comes into picture. The distributed computing application that you are developing. So I'll come to that later. So the distributed computing concept should be in such a way the amount of work given to individual machines depends on their capabilities. You should not uniformly allocate the work to all the machines, not understanding their capabilities. One way of doing that, so that you even out in a way so that they are able to perform with your previous records what they are capable of. Okay, that is one way of handling that.
Yeah.
Or simply we try to call it as load balancing. Accept?
Yeah. Sure.
Sir, one question. So if there is no shared memory, how do the result of distributed computation get combined together to produce the meaningful overall outcome?
there will be one leader or one machine, okay, which is called as the initiator, okay, which will lead dividing the work to all the machines and collaborating the work after they complete their job and show the results. They stitch it again. The work is first divided into pieces given to all. Once the result are there, they are all stitched together and presented back. One or two machines will take care of that responsibility again.
Okay.
Able to make sense?
Yes. Thank you.
Go ahead. Now, this is the important point. Now we'll come to a junction where we understand what are we learning in this subject. Why do we need to? Okay. I said distributed computing will take care. Distributed computing will make sure of all these things. Then what is this distributed computing? Where it is coming from? Okay. There is a layer that is built in. Check this out. Take a machine. Take a minute. There are three machines, A, B, and C. Every machine is with its own operating system. Even beyond, I'll say, with their own hardware. Accepted? Might be heterogeneous. Okay. They all can run their own application. Okay. Now, what is happening here? There is a middleware service that is coming up. Don't get confused with the middleware applications. That has nothing to do here. Okay. This is a middleware service on top of which our distribution application is sitting. I'll give you the other side of this. Let's assume I have a machine. Server 1, server 2, server 3. I have three machines. Okay. With their own hardware, their own operating system. They're totally independent to each other. Now, I want to run an application which need to be executed on all the three machines because of its own limitations or capabilities. It requires the power of three machines. Now, when I make the application to be installed on all these three machines, the same application, would they all three work together? Yes or no? They don't work together.
No.
Because they are not linked or related. Am I right? Are they related with each other? So I'll say I have a network which is running. It will make sure they are connected. Yes, they are physically connected. With the help of network, they are all physically connected. Are they logically connected? Maybe I'll say the operating systems are good enough that the operating system of one machine can speak with the other machine. At the OS level, yes, they are connected. Okay, hardware level, they are connected. Physically, they are connected. Network logic protocols, they are connected. Operating system, they are connected. Okay? Would the applications are still connected since the operating system is connected? When I say connected, they are logically related. One operating system speaks with the other machine operating systems. Logically, they are all connected. Okay. So when I say that, would the application running on these operating systems are still connected or not? No, the applications are still not connected because the applications are totally independent. How can I make the applications connected? I need to build an application which is capable of distribution. Not any standalone application is good enough to be executed on this environment. It should have the capability of distribution, meaning it should have the capability to communicate with the other machines which are running on the similar application. Okay, these are the distributed applications. Okay, and the space is missing. There is a layer in between this application and operating system, which is my distributed layer, which connects your operating system and your application together. Stitch both of them. Simple, it is very clear here if you can observe in this diagram. Okay, every individual machine running on its own. Okay, there is a distributed application that is built on top of these applications. Okay, for this distributed application to work efficiently, meaning take the full utilization of all the machines and work together. Okay, there is a layer that is required called as a distributed layer. This distributed layer is the one which contains all the distributed services. These distributed services will stitch multiple machines logically into one machine and multiple applications logically to one application. Okay, and that's when the distributed application can actually work and can utilize the resources of all the three machines. So this is where we are studying our distributed computing. What all comes in this distributed computing is what we'll be studying. Take a minute, analyze yourself. Let me know once you're clear on this point only, we will go next.
So, sir,
Hi, sir.
cluster software is a kind of distributed
Sorry?
mid
Yeah,
layer, right?
cluster software. Cluster software is a kind of distributed. But nowadays, I'll tell you one thing, guys. I'll give you the classic example. I'm much related with the databases. I'll take the example of databases most of the time. When you go back in days of databases, okay, DBMS is an engine or an application which runs your database. Am I right? Okay, database is a database management system is the application which runs your database. Okay, when I install a DBMS application on a single machine, okay, the database is here itself, the application is also here itself, and it runs. Okay, the version of my database machine is a standalone application. Accepted? Now, there is a next version called as a centralized version. In the centralized version, what happens? Two different types of softwares are developed. Can anybody name that? One application requires two different versions: the client version and the server version. They are not same. The server version of the software will go into your server. The client version will get into the clients. Do it make sense here? That's when the clients can speak with the server and get their work done. But the application is both put together. You want to develop an application in a centralized environment, okay, you need to have a client version of the application and server version of the application. If it is a standalone system, single version, which will sit on the machine and work standalone, nothing bad. In the centralized environment, you require the client version and server version. Both have different functionalities. Am I right? Now,
Yes.
when I go for the third one is distributed. If I want to develop an application in a distributed environment, should I go with the client version of the application or the server version of the application?
Server version of the application.
Server version.
So where is the client version then to access the server?
It's going to sit on the client machines, but this distributed version is going to sit on the servers.
No. Then again, it's a centralized version.
It's
When you say
kind
the
of.
client, no. You are speaking at the user end. Forget about.
I think it should be both.
It should be both. Yeah. Meaning, the machine, the application that I'm installing on my machine should act as both server and also as a client, or as both at the same time. That's the beauty of distribution. In a distributed environment, we call them as nodes. Every node is capable of acting as a server when it requires to share its data to others, can act as a client when it needs to connect to the other servers to pull the data, and can act as both at the same time for two different users. For one user or application, it is acting as a server, and for the other one, it is acting as a client. So the application that I'm developing on my distributed environment should be capable of distribution. Simply, I'll say, I won't rather say it as a server or a client version. I'll say it as a distributed version. What is a distributed version? Simple. My regular application, a standalone application, I mean, the application that I built for my standalone system is also with the capability of distribution. Meaning it will support the distribution environment. Meaning it will connect all my machines and make the things work. That is called as a distributed version of your application. What is the distributed version? Nothing but the layer that I'm speaking here, the middle layer, which will connect all this logically. Clear? Yes? I'm trying to give you a vague analogy. Just try to understand. We know
Yes,
flowers,
sir.
right? Flowers, roses, lilies, whatever. Can these flowers all put together form a garland? Full month. जो फूल से बनती है. Can these flowers all put together at one place? If I get all the flowers at one place, would that make a garland? No.
Yes.
What makes a garland?
Yes.
Then they are connected with each other. Meaning, if I make them bunch with each other, I use a thread to connect all these flowers together and make it as a garland. Am I right?
Right.
That's when the purpose of a garland with all the fragrances at one place and can be decorated. Same is the case here. You need to have a connecting thread. What is the connecting thread here? Connect multiple machines and multiple applications.
Network.
Physically, it is network. Logically,
Middleware service.
Middleware service, nothing but a distributed layer or distribution layer. The distribution part of your application. These are the separate set of services that are required on top of your application. Application has its own core functionalities. Yes. But for this application to run in a distributed environment, it should be able to support the distributed services. So it should have all the distributed services and the algorithms related to the services in this layer. That's when it makes perfect sense. Able to understand?
Yes. Sir, this Google Drive, and OneDrive can be example of distributed application.
Yes. Perfect.
So the distributed middleware service is just one single service installed on multiple OS, right?
I'll come to that. See, generally this comes as a package with your application. When I want to have an application for my distributed environment, the vendor will develop the application considering the distributed environment and embed all the services that are required into your application itself. Meaning the application should be distributed capable, the operating system should be distributed capable, and there should be something that is coming in between, like your middleware services, which will make all these machines connect to each other logically. And all this happens via network only. Physically, everything flows through network, but logically they are connected at different level.
And this is part of application package only, which the developer is going to develop.
It can be part of the application package, or it can be a third service which comes into picture. I mean, third-party service. I'll give an example.
Okay.
Most of you are aware of the cloud computing architecture.
Yes.
What is the very basic end of our architecture? Cloud computing. We have the hardware. All right. Every machine, there are multiple machines which have their own operating system, okay, and everything. What you have on top of that, where you run your host operating system, you will have a separate operating system that will running on top of all these machines, right? Or a guest operating system. What is there in between to link all these machines together?
Hypervisor.
Either hypervisor.
In general, it is called as a virtualizer. In cloud, we call it as a hypervisor. What is the role
or
of
container
hypervisor?
engine if it is container based?
Let's not get into that level. Just the hypervisor. What is a hypervisor? What is the role of hypervisor?
It
Hardware
allowed to
virtualization.
run.
Logically
Hardware
connect all these individual machines together and create a guest operating system on top of this. Am I right? On top of which you create your virtual machines. Like the hardware hypervisor, which is supporting mostly in the hardware of your cloud computing. Again, it is part of software also. Similarly, here it is the distributed layer or the middleware services which are making this happen. Okay. Simple guys. If you want one machine, just to think about a regular PC. If you want to share a file from one PC to another PC, use a FTP, file transfer protocol. It's a piece of software which will connect both the machines, connect through the network logically, and make the file transfer happen. Am I right? This happens at a file system level. Similar to make such services available across multiple machines, not just to transferring the file, but to share multiple services and run an application at multiple level, you use a distributed layer in between, which is a middleware service. Or your application is coming with this put together and makes things much more easier. Able to make sense? So you look into this, you'll understand. So what is the relation between the software components on a machine? Okay. So you see the distributed application which is sitting at the top. Okay. This is your network protocol stack. Okay. This is your network. This is your operating system of the machine. They both are being overlapped, or the control on operating system and the network protocol is on this distributed software middleware services. on top of which you have your distributed application running. Meaning the services that are required from the operating system, the services that are required from the network are all and now under the control of distributed software, okay, which supports the distributed application. For the distributed application to run on multiple machines, this is happening at each and every machine. Okay, so this distributed software will act as a buffer in between, okay, taking the resources from the individual machines. It will get the control of the services of operating system, gets control of the network protocol, and give these services to the distributed application which is running on top of that. So in between, it is acting as a buffer to make all these things happen. We will study what all the things that are happening in this distributed layer or the distributed software. Okay, you see this, it will be much easier. Compare what's all in this. You see individual machines, 1, 2,
So what
3.
is the distribution protocols? In the previous slide, there was the extent of something like on the side, extent of distributed protocols.
They are getting narrowed. It's a funnel thing that is shown. The distributed protocols are very wider at the distribution application level, and getting narrower down the line, it gets to an individual machine. At an individual machine, it is on its own, right? When you see this across multiple machines, it's only one machine that has been shown here. The funneling that is happening. On the top of the layer, you see it is entirely distributed. When you get a layer before, you see the individual machines' capabilities. When you go down to the hardware level, it's the individual machines that are independent to each other. That's where the autonomy comes into picture. And they keep on relating layer by layer to make the distribution happen. Now, if you compare this, 3 machines with their own kernel and their own operating system services along with the network, with a common network, which is the physical connectivity between these machines. This is a networking operating system, meaning the operating system is networkly related to each other via the network, meaning the operating systems can speak with each other. They are independent operating systems, can be homogeneous or heterogeneous, but they are able to speak with each other because of the network capability. Because the network protocols are good with the OS, they can speak with each other via network. The communication happens via network. Okay, on top of which you have your distribution application sitting. This is one way. Okay, this is a complex application directly on network stack, has to solve distributed computing problem. It's a headache of the application how you want the distribution to happen. Neither the OS nor the network will worry about that. Just give the services. It is your headache as an application how you want to utilize, make the things happen. But coming to a distributed operating system, now there was an evolution where the operating system is now capable of distribution services. Rather than seeking services from the operating system at a distributed layer level, the operating systems are now distributed capable so that the operating system will communicate with each other. Okay, they can directly communicate with each other. Just like a distributed application sitting at the topper level, even the operating system is also an application which is sitting on your kernel, which is again a distributed capable. So it would be much easier and more handshaking to have a distributed application running on top of your distributed operating system. This is a networking operating system model. This is a distributed operating system model. Able to get a clarity on this?
So both the capabilities do. So an operating system have both the capabilities, right? Networking OS and single operating system. Do they vary?
Now the point to be understood is that by default operating system have all the capabilities. Now it is vertically growing. Now it is horizontally growing across multiple machines. It is now able to relate multiple machines and go ahead.
Same operating system.
Yes. Can be same or different also. Can be heterogeneous also. Not necessarily it should be homogeneous.
But when you talk about the operating system, what operating system it is? Like, I'm just trying to understand, just correlating with the Windows one, which we normally use. I mean, which operating system does have?
Windows servers?
Yeah, Windows. Yes,
Windows server versions of the Windows. If you go with Windows NT, remember the version of Windows NT back in days on which the XP has been based and Vista has been developed. Even our today's Windows 10 and 11 are on this same platform, NT platform. That's where the networking operating systems came into picture. So this refers to the first model.
Networking this is novel network were also the network of operating system, right?
Yeah. Now, when we speak of the distributed operating system, the server capable operating systems are all distributed operating systems. Most of them. If it is a centralized, it's a different thing. Just think of the host operating system or the guest operating system on top of your hypervisor in a cloud environment. That's a distributed operating system. Am I right?
Do we have such capability on the Linux side as well?
Yes, yes. And cross-platform is also available. Linux is more supporting actually. I am not clear of the examples of distributed operating systems. There are many. I'm not clear with the naming convention of this because we don't use most of the applications. There are. And in fact, Windows is now able to speak with Linux or Unix, and they are able to cross-platform also with the distributed capability across them. That's the beauty that is happening with the distribution. That is more needed and required. Able to get it?
Got it. Good. Thank you, sir.
Otherwise you can't even visualize the distribution happening if it is not cross-platform. For the purpose of cross-platform, only distributed concepts have been developed. It's not that distribution should be supported. Rather, because there is a cross-platform that is happening, okay, distribution came into picture to nullify all this and have a common platform for everybody to work on with. Distribution makes it possible. Clear? So since your operating system is on distributed layer and your application is also on the distribution, it would be easier to program them. The applications that you try to develop on this environment or the programs that you try to write on this would be much easier because it's not required to think on two different levels of operating system and application. Now everything goes hand in hand. There's a better handshaking at this level. Easier programming where complexity is handled in distributed middleware or OS services. It's not required for the user meaning the programmer or the developer to worry about these layers. The applications will take care of that. He can concentrate only on developing at a single platform rather than trying to understand what is happening at OS, what is happening at application, and how do we relate. Rather, they have a better coordination now. Things go much easier. Able to relate?
Sir, I have a question.
Yes.
Sir, in distributed OS, so we talk about type 2 hypervisor.
Sorry?
Like in distributed OS, we talk about type 2 hypervisor. No? So basically, we can run directly on the server.
Yes.
Okay, sir. Okay.
So I'll give you one thing. Your cloud computing, whatever the example that you take and you work on, is a totally based on distributed computing. The core of cloud computing is a distributed computing. Without distributed computing services, without distributed computing concepts, there is no cloud. Cloud is one of the technology which is built using distributed computing. Able to get it? One
yes, sir. Yes, sir.
flavor or
Yes, sir.
version of distribution. One particular configuration of distributed computing is cloud. Another version is cluster. Another version is grid. Another version is IoT. Okay.
Sir, what is the example? What is the example in the cloud computing for distributed operating system? Is it OpenStack?
I didn't get your question actually.
I mean, so how can you give the software example like distributed operating system in terms of cloud?
Cloud generally they have their own vendor-based operating systems based on the cloud service provider. It's not an open source kind of thing. To my best know.
No,
That's where
OpenStack.
that's where the clouds differ with their own unique advantages. Every cloud has a competitor in the market, have their own capability because of the uniqueness that they provide with each other. Okay. So they are definitely capable of distribution. They need to be, otherwise they can't make this happen.
Okay.
Maybe just a search for some distributed operating systems. Examples we can get.
So Hadoop, like for an example, is a distributed.
Those are all the applications, right? Hadoop is the applications. It's a distributed applications which is running on top of your operating system.
Okay.
In general, most of the operating systems that you're getting at a server level are distribution capable, except for PC versions. PC versions are more stripped down versions of them, right?
But we are not using those.
You don't use it. Maybe depends on the workload that you have. The
No.
will use it.
Windows servers operating systems we are not using in the cloud environment. There might be something similar operating system to support the cloud environment.
No. AWS develops their own operating system for their cloud services, which is more handshaking for them. Because see, in cloud, the beauty is that every service provider, the cloud service provider will create their own set of hardware and their own set of services, which are copyrighted only to them. Not necessarily they go in public and generally use it, but they get it from different vendors, but only patented to them. Okay, not necessarily they are publicly accessible or worked on. The top layer is where you get access to the users.
Okay.
Make sense?
Okay.
So examples of distributed systems where all we'll be using cluster computers, banking applications, internet caching services like Academy, distributed databases, peer-to-peer systems for content sharing, content delivery networks. CDNs come here. Okay, media streaming systems, your OTTs, real-time processing like aircraft control systems, aircraft operating systems, real-time operating systems are also part of this. IoT and sensor devices. These are all part of distribution systems. Okay, they take the core concepts of distributions to make all these things happen. Maybe you can add more examples as per your work experience that you people have. Right? Now, what are the motivation factors? Based on what points we are going for this distribution. So inherently distributed computation. See what all we discussed are now here. Okay, nothing. I'll quickly go through. Stop me wherever you feel to have some clarification. In many applications such as money transfer in banking or reaching consensus among parties that are geographically distinct, the computation is distributed. So mostly distributed things. And resources sharing. Most of the time we try to share our resources with respect to hardware, software, or your peripheral devices also, for which again distribution comes into picture. So resources such as peripherals, complete data sets in databases, special libraries, as well as data, okay, cannot be fully replicated at all the sites. Practically replicating all the data across all the sites is very complex. And at times it's not possible also. Okay, for which reason we go for distribution. We divide the data across multiple locations and start accessing them. Because it is often neither practical nor cost effective. Further, they cannot be placed at a single site because access to such site may be a bottleneck. What if you try to have all the data at one single place? And what if, because of natural calamities, the building comes down? You lose the access. So your distribution system is able to give you a better fault tolerance mechanisms and better replications also. We'll discuss all that later, how and why. Therefore, such resources are typically distributed across the systems. For security and safety concerns also, they are distributed. Distributed databases such as the DB2 partitions the data set across several servers, in addition to replicating them at few sites. Just an example. Access to geographically remote data and resources, as discussed, you will be able to access them across multiple locations, distribute them, okay, uh, and collect the data also. See, collecting the data from different locations, maintaining the data across different locations, processing them at different locations will all be possible because of distribution. Enhanced reliability. Obviously, the system becomes more reliable because of the better backup mechanisms that you prepare, or because of the kind of reliability that you redundancy that you create, the replications that you create, and the failovers are much better. Okay, so obviously the reliability factor would be much higher. When we speak about reliability, 3 points come into picture. It's about the availability. Okay, the resources are highly available. Integrity. Okay, we need to work a lot on integrity to make sure how the systems are consistent and integrate, and better fault tolerance mechanism. When we speak about fault tolerance, it is about the tolerance of an entire system towards failures. Can be software, hardware, or network at any level. What is the tolerance level for a particular system during its failure, and how better it can recover and how better it can stabilize is defined by fault tolerance. So these all three contribute to your reliability factor. Okay. Then increased performance to cost ratio. See, we spoke about efficiency and economy. How distributed environment is able to be more efficient? Can anybody answer on that? Where is the economical point that is coming here? Why distributed systems are less cost? The cost to performance ratio is very less here. When compared to, can you compare this with what? I want an answer. Distributed computing environment can be compared with what? the high level of processing power, the high level of task that they are doing. Okay, they are compared with what?
Utilization.
What are the machines which are capable of doing? Sorry,
Resource
Parallel
utilization.
system.
no.
Parallel
So
systems.
resource utilization matters. Then
Cost
Parallel
effectiveness.
computing.
Supercomputer.
Supercomputers.
compare the capability of supercomputers. Now we are able to reach beyond the capability of supercomputers with the help of distributed environment with a fraction of cost. Task that is capable of the tasks that are required for the supercomputers to be done. Now the distributing computing environments are able to do that much better than the supercomputers with a fraction of the cost. Got it? Nowadays, when we want a high complex jobs to be worked on, weather forecasting was also required to be done by a supercomputer, not by any normal PC. But now that can be executed with the help of data centers or the clusters. Clusters are nothing but your distributed environment at a fraction of a cost. The cost is much lesser because the establishment of supercomputers is complex. The cost of maintaining them is high. Okay, their architectures are different. You require a different set of applications are totally, you can't run your regular applications on that. The operating systems are different, the environment is totally different. Now they are being totally replaced by your distributed computing capabilities. That's why the performance ratio is high. That is what is one of the motivational factor to develop a distributed environment like anything, rather than depending on supercomputers, which have its own limitations. Clear?
So, so, sir, when you say the supercomputer, by saying the supercomputer, do you mean the quantum computers?
Sorry, which one?
With the term supercomputer, do you mean quantum computer?
Not quantum. Quantum is not just in regular usage. Quantum is still in under research. Quantum computing itself is a totally different field. We are speaking about binaries here.
Got it. Got it.
Either supercomputers or distribution is in binaries.
Okay. Okay. Okay.
Quantum
Understood. Got
computers
it.
is
Thank you.
on qubits.
And so,
Okay.
Not going
my
there.
one question is there, sir, how we can differentiate between distributed computing and the supercomputers?
Supercomputer architecture itself is a different. So the comparison happens with respect to the performance and the cost to performance ratio, and also the capabilities and the response time. Okay, the way supercomputers works is with floating point operations. The architecture itself is different, but with the distributed environment, the basic PC architecture or the very common computing architecture can be multi-folded and can reach to the capabilities of supercomputers. That's how we are able to do that.
Sir,
Yeah.
Okay, sir.
Sir, if
basically in
sir, can I ask a question?
Yeah.
Yes, sir. If I'm not wrong, the supercomputer is nothing but like collection of powerful computers, no, sir. Like the
Yes.
way we are going in like distributed computing. So
Yes.
what is the like
The architecture is
differentiation between?
different. That's what I'm saying.
Okay.
Both work on binaries data only. Their core concept is binaries only. But the way the supercomputers are architect is a total. Do you think the Windows operating systems and Linux operating systems are same? Their architecture is totally different, based on which the processors are also different. Am I right? The processor
yes, correct.
architecture
Yes,
is
sir.
also different. Similarly, the way the supercomputers are designed and their architect is a totally different with respect to both hardware and software. Okay. Now we are able to compete with the supercomputers in a much larger scale by using distributed computing. Simple guys. Now the recent supercomputers what are all built are nothing but clusters. Clusters, the cluster computing capabilities are now treated as supercomputers. Okay. The clustering is nothing but distribution again. Clear?
Yes,
Let
sir.
me this is the last point and we'll have the questions. Scalability is another factor. We can scale any number of systems. We don't have any limit on the number of processors that you can have or the amount of RAM or storage that you can have. You can keep on scaling up, which is not possible in a centralized environment. You have certain limitations over there. Modularity and incremental expandability, obviously, is more modular system. As we discussed, these are all the points that we listed out initially, and I checked you people what is your understanding. Okay, so these are all the factors which made distributed computing evolve. Because of all these advantages we are looking, we are able to go with that. Definitely, there are also disadvantages and complexities that will come with the distributed computing that we'll discuss down the lines. Some examples like Netflix is using the distributed computing capabilities to make this happen. Okay, the content creators or the network stack, I mean the Netflix stack, the distribution and the playback is a totally on distribution and uses AWS. Okay, this is an example just to check it how it works. Okay, so this is where I'd like to hold for today. I don't like to go further. The time limitation. We still have a couple more minutes left out to officially close the session, but I'll be still available if you want me to answer any of the doubts or questions. Okay, we'll we'll pause the class for here for today's session. Okay, now we are good to take any doubts,
Sir,
questions.
one question here. Ravi
Yes.
just said. Generally, we in most of the distributed systems, especially in the HPCs and all, there is a job schedulers also in it. So they are
Yes,
also
yes.
considered to be as a distributed
No.
application
Those
or
are the
middleware.
tools. Those are all the tools, utilities, and applications that are built on top of your distributed environment. They are not part of distributed computing. They are on top
Hmm.
of that, which can handle distributed environment. But they
Okay.
should be capable of distribution. They should have that quality so that they can
Hmm.
go across multiple machines and make it. So they should have that DNA of distribution in them. Okay, they should be built on that line.
Okay. So similar, so those applications we can see like example I'm giving like Slurm is one of that, right? PBS another. Similar kind of application we have in the Kubernetes as well, right?
Hmm.
Which actually handle the cluster communication, resource
Yes.
allocation and all.
Yes.
So 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 ideally the functionality, the backend technology is all same, right, for all these application.
Yes.
Okay,
It's all runs
understood.
on the core of distribution. The core once we go through 3 or 4 modules, you'll understand what is the core of distribution. Then you'll be able to visualize how applications or different technologies are developed with the distribution at its core. Your cloud computing is developed based on distributed computing. Your clusters are developed on this. Your grids are developed on this. Your peer-to-peer, okay, your IoT devices, and there are multi more examples. Okay, I'm not speaking about applications. I'm speaking about the technologies that are developed. Your storage technologies like NAS and SAN are also part of distribution. Okay, they're all built considering distribution at its core. Okay,
Understood. Understood. Yeah,
this
thank
is the
you.
core concept.
Got it.
And if you ask me a question, can you show us where is this? I'm not able to because they are at the development of the product, not the application. Okay, so that's the one challenge that I face every time. I can't show it where it is, how it is. We can only experience it when we work with them. When you
Yeah.
work on a distributed environment, you can relate these concepts. Yes, because of that, this is happening. Okay, you need to visualize a lot.
There one question here.
Yes, please.
Yeah.
Guys,
So
one
like
second.
in
Before that, one second. So, guys, since it is a time 12:30, officially the class is ended, but I'm still available. I'll take the questions and answers. But I don't. People who are done, they can leave the session because I don't want to show that this was an extended beyond the time session. If you have doubts, clarifications required, you can stay back. We can discuss, but not that. Officially, we are good. Okay. People can leave if they have nothing or no questions or doubts to be done, or you can participate in session. This is the offline thing that we are going now. Clear? Thank you. Thank you for all the participation. Now I am open to take any questions, please.
Thank you, sir.
Yeah, please.
yes, sir.
Sir,
So
Yeah.
go ahead.
so the main reason why distributed computing is becoming more economic or efficient to use is because nowadays, for example, we can take the example of cloud. There is this pay as you need model. Like you don't have to set up the
Yes.
entire infra in your place, and you can
Yes.
turn it off, turn it on whenever you need, or you can create
Okay.
clusters as per requirement. So that
You
could
are
be the
able to
main reason.
efficiently utilize, and it can be more
Yes,
economical.
like you don't have to buy anything in bulk. It is you
Yes.
can scale it whenever it is required, turn it off when it's not required.
See, you're seeing a cloud computing at a level of only one thing that I can say is that the cloud is being looked at a user level, end user level, or just at a developer level. But think about the product developers and other things. There's a lot more in distribution rather than just As a user only, you're able to see so many benefits. At a product development, there is a lot that will happen in this distribution. You are looking only at the cloud. Think beyond. There's a lot more.
So I actually have a doubt. So initially
Any more
you,
questions?
sorry.
Your voice is breaking. I'm sorry.
Can you hear me now?
Yeah, it's better, please.
Yeah. So initially you just mentioned which is the most secured system in the globe. I believe distributed is not. If I'm wrong, if you can help me out with it. So because there's a larger surface area, so the security might be little compromised.
No, we'll take this question at the start of the next session. Kindly remind me.
Okay.
I think a few people have talked. I'll take it in the next session. Okay.
Okay.
We'll
Sure,
start with
sure.
this.
Yeah, sure. Thanks.
Yeah, the recordings are available for these sessions. For sure, they are there. Questions, yeah, I already answered the other question. For multi-threading used is an example of distribution. No, multi-threading is not part of distribution. But of course, multi-threading comes as part of comes in the concept of distribution, but it's not part of distribution. Multi-threading happens on a standalone system also. Not necessarily it happens only in distributed environment. Right? Yes.
Yes, sir. One question here, like,
yes, please.
yeah. So like in Kubernetes, when we talk about Kubernetes, because we work on Kubernetes, so we just try. I'm just trying to correlate this distributed computing to the Kubernetes. So we have a master node and worker node, and in worker node we have our choice to place our guest operating system. Like in a worker node, I can Linux, Ubuntu, whatever I can install and run my actual application. Right. And all those nodes can communicate internally in the Kubernetes backbone. I don't know how Google developed that K8 system.
Yes.
Right. So you mean to say they developed the distributed operating system at that level so that the control plane and master worker plane can interact each other underlay. Is it right?
I'll give you
Understanding?
one thing. Even yes, you're right. But one more thing that happens here is that what all you are trying to do here is a guest operating system or the guest thing that you are trying to do. But there is basically a backbone that is a host operating system that is actually running in the background, which you are not aware of. So that will connect all these things and make the things happen. Okay.
So it means when I install like K8 in my machine to understand this, I mean to deploy Kubernetes locally, underneath of that K8 installation, that distributed operating system also come.
Running.
Is it?
Yes.
Is it running? Is it right?
Yes.
Okay.
Yes.
Okay.
I'll tell you
Okay.
one thing. If you are taking a fresh machine on a AWS console, you're trying to develop a fresh virtual machine. Okay. Do you think the machine that is given to without any operating system is blank and you are then installing or choosing your operating system? You're doing that, but by default, there is something already running behind that to make this available to you. If there is no operating system, how are you even able to see a virtual machine that is built by you? There are services which are running in the background. Okay. It gives you the illusion that you are on a blank machine and you are installing whatever you want. It's all virtual. Remember the term virtual, very important. Right?
That is hypervisor, right? The big hypervisor is running in cloud premises. Is it right?
Yes. And even beyond hypervisor, there is a host operating system on individual machines.
Yes.
Hypervisor can't just be on air, right? It should land on an operating system.
Yes, correct. So there is a main operating system in data center.
Host operating system.
Yes. Thank you.
On top of which you have a hypervisor. On top, you create your guest operating system. It looks that the operating system that you are creating is fresh to you, but actually it is a virtual thing that you are running. Behind that, there are already operating system and everything running for you. It's only giving you an illusion. Yeah.
Even on the virtual machine, if I go and install Linux box, then architecture should be like host and guest, two guests, right?
Yes. Host is not visible to you. You are
Yes,
not
host is not
accessible to the host.
Okay.
Right?
Sir, I have a question related to the slide, sir, in which the network operating system and distributed operating system was shown, sir. If we can go to that slide, sir.
I need to start sharing the screen once again. So kindly make sure because of me you're not getting delayed for the next session. I don't that. I don't mind spending the time, but that should not be a constraint. Okay. This one.
Yes, sir. Yes, sir. Sir, my question is like in the networking operating system, both are capable to work in distributed environment. Like in the
Yes.
network operating system, the machines are having different operating system and they are interconnected through the network, and the application has the distributed functionality. So they are able to execute that common purpose. Same thing goes for the distributed
Operating
in
system.
distributed operating system, sir. So I want to know, sir, where what exactly is the difference, sir?
Advantage.
Because
See, the advantage is that now here, if a user is trying to work on the distributed application, okay, and he need to get some OS and kernel services. Simple. If a user sitting on machine A want to go and access some data in machine C, okay. In the first case,
sir,
the network operating system, it should go via operating system, via kernel to the network and get it done. Okay, because voice is not able to speak with each other.
okay, sir.
But in the distributed operating system model, it is not required to go through all these layers. So directly, a machine can speak with the other machine at the operating system level itself, or maybe to the application level itself, if possible. Meaning, one machine processor, machine A processor, can go and read the data of machine C in its RAM. Can access the RAM of machine C. Machine A processor can read the RAM of machine C. If the distribution is at a higher level. If that is not the case in networking operating system, it need to go and request the operating system. Via operating system, it need to go and get the data, which is more complex. So better handshake.
Okay. Because in this case also, sir, like you are saying, if machine needs to access the data of machine C, though the application is distributed, but still it needs to get connected through the network only.
I mean, the physical flow is through network, but the
Sir.
access or the permission is at the distribution layer, not required to go to the OS services request and check, and you need to write a separate service request for the operating system to happen. But that is not required at this level because there is already an understanding stating that we are all one, we are all on one good environment, we can share whatever we want. There's an understanding that is already done.
Okay, sir. Now I get it. Like it is similar to like in the networking, we have different layers, like physical
Yes.
layer, then TCP/IP. So
Exactly.
it can be communicated at the top layer. No need to go to the bottom layer and take those
Exactly.
access and permissions. Right,
Exactly.
sir. Right,
So
sir.
that your
Now got
performance
it,
increases, response time decreases.
sir.
It is what we generally call better handshaking.
Right, sir. Right, sir. Thank you
There
so
is a
much,
MOU or agreement written between these machines that we can free to operate.
sir. Thank you, sir.
Thank you.
Yeah.
Uh,
Sir, I have a
so
follow-up question.
Yeah.
Okay, on the same slide.
Okay.
First of all, thank you for setting up the context that actually helped us to understand things to a very good level.
Please.
Typically, this context setting is not done in the right when people start getting into presentations and just talking about geek words that doesn't help to a good degree. So thanks for doing that. As far as this particular slide is concerned, the networking OS part, here responsibility of communicating to another machine, sending requests, getting the response, and then absorbing that response. All those responsibilities are taken care by distributing application, as in underlying OS is not going to help you, in short, right?
No. I'll correct you here. The distributed application should raise a request to the operating system. Operating
Right.
system will get to the network layer and then get connected.
Okay. Right. So there is nothing readily available, as in it is
No.
application's responsibility to know that I am a distributed application and I'm running on multiple hosts that way.
So now
But
the load, now here the load on the distributed application is getting higher.
exactly. I was getting that. Yeah, right. So it has responsibility of knowing that I'm a distributed application. That's the point which I'm trying to come at. So overhead needs to be owned up by distributed application. But when we switch on to the other
Sorry,
portion,
I just lost you. Yeah,
okay,
please go.
when we switch on the distributed operating system services kind of analogy here, how multiple as in responsibility is broken into two pieces, as in distributed application will have lesser responsibility in context of knowing that it is a distributed application and it needs to communicate to multiple nodes kind of a thing, right?
Yes, it will by default help you out in making the things happen.
Perfect. Now, just
It is
to
it is
kind of
it is it is as simple as you communicating with your team members and you are trying to communicating with your other team members. Within your team, the communication will be easier and you can get
that's
access to
correct.
the resource there. But if you are trying to
That's
go and communicate with the neighboring team, you require to go through your manager or the process.
I
Think
see.
about the same communication happening
Yes.
across organizations.
Agreed.
Within organization, it would be much easier because you all know you are on the same compliances and other things. But if it is across organizations, the compliances matters a lot, and you need to check with more things. But when there is a collaboration, you have an easy bridge to pass through all these things.
Agreed. Agreed. Just mapping this concept to Kubernetes, let's assume that as an example, because we can envision it a bit. Now the distributed operating system services layer becomes the Kubernetes part, right? Wherein it can run on any number of hosts. As in the consumer of Kubernetes doesn't need to worry about how many hosts are there and so forth, right? And the communication pattern between them. So can we say distributed operating system services job is done by Kubernetes cluster that way? We talk to cluster and we get the job done.
Yes, it's a cluster operating system which is making your things much easier. That's why we develop a separate cluster operating system. As simple as that.
Okay, now with that, one particular machine accessing some else machine's RAM directly, wouldn't that be a security problem?
That's where the security layers comes into picture, where the access and access mechanisms or role controls, all these things happen. So, I mean, it's an organization and your SOP level that will define who has access to what need to be restricted. All this comes into picture at a later part. We are speaking about the technical part.
Okay, I see, I get you. So this is
The
just a
bridge is
mechanism.
open.
So
The
bridge is
bridge is
there as in
open, but
right.
who need to be allowed is at the user level. The
Agreed,
organization level, who will allow what to what.
agreed. That helps.
The bridge
Okay.
is built. Whom you want to allow is your thing.
Right, and while networking OS, there is no bridge, full stop. You have to go through network and get your job done, kind of a thing. There is no shortcut in a way to get the
But
job
here
done.
also, don't get confused. In either of the models, the data or the request, everything flows through the network only
Yeah,
physically.
absolutely. Yes. It
Logically,
has to.
logically, they are collaborated to make the things much easier.
Right. The easiness with which they can talk to each other is the point which you're trying to come at. It will be very easy in distributed operating system, while in networking counterpart it is not.
It is as good as virtually it's all one single system, not individual systems that you're looking at.
Oh yeah,
At
agreed.
application level, you're not worried about to understand how many machines are there, which machine I should go and communicate. Just to send a request to the OS will take care where it need to get it from.
Agreed. Okay, that helps. Thank you.
Sure, thank you.
Sir, one doubt on this. Like Yuvraj said, on the Kubernetes cluster, there will be a distributed operating system which will work with all the different nodes. Does same works with EC2 instances? Like if I create a R6A 32X large, which is like almost 1000 1 TB of RAM. So is there multiple host which actually creates a one EC2, and the RAM can be shared from the different host
to you
for one EC2 itself, right?
Yes. See, for you, it looks like as a one large machine with 1 TB. Okay.
Yeah.
But physically, it is not the case.
Okay.
Do you expect this 1 TB is physically coming from one machine?
No.
And it can be spread across, not necessarily if one machine is capable of giving you 16 gigs, not entire 16 gig of one machine is allotted to you, even though it is physically available. Only a part of that will be available. And mind you, one more thing, 1 TB is not a constant memory that you are getting from a single source. They keep on switching across multiple memories based on the need, demand, and load. There are failures that happen. Multiple machines might have failed in between, but you don't sense it because the AWS cloud service without the user knowing, and they keep on giving you that service. That's where the reliability comes into picture, high availability factor. Okay, Physically,
Yeah.
there's a lot happening with the help of hypervisor. This the user is not experiencing. You are given a smooth sail to make sure what is required is given to you. But internally, there is a lot of switching that will keep on happening.
Okay. Yes. Yes.
And not necessarily every time you access the same set of hardware, unless until you are working with a private cloud. It is a private cloud, it is guaranteed. The public cloud, no.
Okay. Clear, sir.
All good?
Yes.
We are good to close the session. So
Sir,
kindly make
one
sure
last
I'm
point.
not killing your time for your next session. Okay?
No, next session I guess is in the evening, so we don't have any classes after
I
this.
mean, few may have, I mean, it's a pool of multiple people, right? So
Yes,
officially we are
correct.
done by 12:30. I'm open for discussions, but I mean, it should not be a complaint stating that escalation. I'm taking too much of time, and because of which they are not getting enough time to catch the next session. Somebody who's having a next session, please leave the session. We can take the questions anytime. I am available. We can discuss, not an issue. Okay? Please. Please go
So
ahead.
basically, in this course, distributed computing, we would be looking into the backend of how things work, like how in the cloud environment or in distributing computing environment, how the requests are transferred or load is balanced. Because as you told, as an end user,
No,
we are not able to
no.
see what's then the
That's what
happening.
I said. I can't even show that. I can't even show that. I can't even make you understand that. We'll discuss few of the concepts where you'll be able to relay how this is working, and you can have a
Like we can get a
visualization
theoretical
how it
idea, like how it is running
exactly,
in the backend. You
exactly
can't do
how
it,
it
of
can
course,
run.
in practical way. Yes,
It's not possible because this is part of the binaries that will happen at the product level development where these are
correct.
embedded and are
We
paid for.
cannot
What we are
access
learning
that. Yes,
and also what we are all learning is at a very basic concepts and at a very old concepts, which can give you a very
understood.
good understanding on how these things are able to advance.
Basically, we get a conceptual idea of the entire thing that is that is how it is running in the backend of the process.
Yes, 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 yes. I mean, that should be the purpose of this course for you people. You should be able to get
Yes.
related with the things and should give. See, it is not the examination or the marks point of view that you should be attending this course. At a PG level, particularly, it's for some understanding and relevance to what you're working on. That should solve the purpose.
So that we can use it or relate it in our professional lives as well.
If you can do that, that's the real outcome. Fine.
Yeah, sir, one maybe lateral question
No issues.
in this particular regards. A person who uses Kubernetes but doesn't know how distributed computing works, and a person who uses Kubernetes and how distributed computing works, how both of them are different from their skill set, or
He can be
would
more
that make
efficient. He can be
okay?
more efficient and can make good utilization and performance of all the services that are available. That's what I can say. Somebody who knows the syntax and somebody who knows logic. What is a 5 cross 4? 5 4 is
20.
how this 20 arrived? Is it because of 5 times 4 is 20 or 5 is added 4 times?
Both of them are same, as in result wise.
Result wise
5.
same, but concept is also same. 5 times 4 is nothing but adding 5 for 4 times. That is what
Correct.
multiplication is. So
Correct.
understanding
Correct.
that concept gives you a better grip and control on your work. But simply you can say 5 4 is 20. Both are right. But if you have a better understanding, you can scale up.
Okay. Okay. Because typically, if you see, all of these things are looked as black boxes as far as application development is concerned. So
Nothing but.
if I'm using Kubernetes, I need to know how to use Kubernetes, how
I don't teach you
Kubernetes
the
works.
tools. I don't teach you
No,
Kubernetes.
no,
I
I'm
don't
just
teach you the tool. If you can relate the
not.
concepts in the Kubernetes, you can be an efficient developer.
Okay.
You
Efficiency is
can make
something.
efficiency comes into picture. You can be little unique and you can stay apart from others and you can maybe you can show the edge. Your understanding would be much better, I can say.
Agreed.
Your understanding on the concepts or the new things would be much better.
Agreed. Okay. Thank you. Just FYI, your battery is about to die.
Not a problem. It's 13%
Yeah.
still. Good.
Yeah. Yeah. Thanks. Thanks. That helps. Actually, Typically people kind of worry about how to use the tool, and as long as they know how the tool is used, Kubernetes is just one example, they're happy. They're happy.
Yes.
But there are certain set of people like me who feel that if I know how it works
The anxiety.
inside, then
Anxiety that
that
comes.
correct. Like just having a black box kind of analogy doesn't help me to a good degree. As in, at least I should be comfortable about how it is working. Is something which I feel more comfortable with, as
It is
against
as good
using it
as
as a
it is as good as a set of employees who are trying to satisfy their manager or trying to develop something more beyond that. That's how I see it.
okay. It has a negative part though, wherein you have to spend time
It's
understanding things to a good degree.
our satisfaction, our interest is what it all matters. There's nothing good or bad. There's nothing right or
Okay,
wrong. What is that
agree.
we are satisfied with?
Yep, makes sense. Thank you.
But fine, we're all good, guys.
Yep.
Yes, we're good for now.
Yes.
Then we'll end the session. The
Thank you
recording
for
seems
the
to be made
session,
available
sir.
automatically.
Yeah.
Thank you,
Thank you,
sir.
guys.
Thank
Thank
you
you
for
very
your
much.
time.
And I thank you all for active participation. Without active participation, it would be a monotonous read of my slides that just keeps on going. Okay. Thank you all.
Correct. Yes.
Correct. Like by only
Both
discussing, we can
sides.
like we can go deep into the subject and understand the, as Yuvraj said, the inner workings instead of just assuming as things are and just getting the job done.
Yes.
Yeah. Thanks for using this analogy, sir. As in the
Thank you.
style of teaching is really good. That's going to help us a lot. As in
Yes.
understanding wise, that's going to help us a lot.
It's the understanding that should keep on going. That's
Yes,
the main.
Correct.
and like
Reading
if
slide is something which we can do on our own, anyways.
It's
and
not required to dedicate your time to that.
the more examples and case studies we get, it would be better to correlate and understand instead of just
That is a
seeing the
little
points.
that is a little difficult in this subject. That's what I'm saying. I was like
Yes,
it's been
correct.
more than 10 years I'm teaching this subject, but unable to get any use cases or any
Acha.
examples. It's getting real tough. It's not easy to get into that level, but we'll try to
Okay.
keep it more related and understanding. Okay.
Okay, so then we have to be more like visualize more on our end to understand the concepts.
Exactly.
I guess.
Be available during the session and involved during the session. That would be more than sufficient for everything.
Okay.
Perfect. Thank you. Thank you very much, sir.
Thank you, sir.
Thank you, sir.
Thank you all.
Thank you, sir.
And I'll end the session. Nobody else have anything else? Thank you.
That's all. Thank you,
Thank you,
sir.
sir.
Thank you all, guys.